In this video, I'm going to walk through how we simplify some square roots and simplify some of our different rules that we have going along with square roots. So the first thing we need to do is list out some perfect squares that we know, because when we're solving these, we're always looking for perfect squares and that we can pull out, and what is the biggest perfect square that can be factored out of our square root. So we know 1 squared is 1, 2 squared is 4, 9, 16, 25, 36, 7 squared is 49, 64, 81, 100, 121, 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. Okay, so we can put these actual values up here. These are all being squared. 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared. So the biggest question that we're asking when we're simplifying square roots that look just like these that I have across the top, the question that we're asking is, what perfect square can I pull out of or factor out of this square root? Okay, so 25 we know, okay, that's a perfect square. It's listed right here. So the square root of 25 is 5. And I like to draw a visual and look at this and say, well, when we're squaring something, we're actually finding like the area of a square per se. And we know our area of this square is 25. And 5 times itself is that area of that square. So in essence, when we're talking about perfect squares, we're talking about a number multiplied by itself, and the product of those two things is a perfect square there. So what is the biggest perfect square we can pull out of 72? That would be 36. We can write this as square root of 36 times the square root of 2. Square root of 36 is 6, and then we're left with the square root of 2. Now another way that some people like to do this one is the square root of 9 times the square root of 8, right? Because 8 times 9 is 72. Now this is just a different way to do this. But you have to remember, that the square root of 8 still has a perfect square in it, right? Because 4 is a perfect square. 4 times 2 is 8. So we rewrite this as the square root of 9, square root of 4 times the square root of 2, right? Because 2 times 4 is 8. And we bring that 9 down. So the square root of 9 is 3 times the square root of 4, which is 2 times the square root of 2. And we still get 6 square root of 2 right there. So either way works. Whatever perfect square that you find will work, but you need to just make sure that whatever is left in your square root is simplified as far as it can go, if that makes sense. Okay, let's look at this next one. What's the biggest perfect square that goes into 40? We know definitely that 4 goes in 10 times. Well, isn't there the perfect square inside 10? There's not. So we will just split this as the square root of 4 times the square root of 10. The square root of 4 is 2, and the square root of 10 stays. Okay, let's talk about a few different things here. If we square a square root, like we have here, we square the square root, just like that. In essence, we're saying this is the square root of 14 times the square root of 14, because we know something squared is that thing times itself again. And when we see something like this, square root of 14 times the square root of 14, we know our answer is 14. In essence, because the two, or the square and the square roots, are inverses of each other, okay? So I want you to make sure you remember that each of these is just the square root. It's the square root times itself again. And our answer is whatever is on the inside of our square root. So square root of 50 times the square root of 50 is just 50. All right. So whether you see it in this form right here, where the square roots are separate, or you see it squared, just know that is always going to be whatever is inside that square root. If we see some fractions like this, I'm going to do this middle one first. Okay. Remember, we said that we need to multiply by some form of 1, because if we multiply a fraction by anything other than 1, it's going to change whatever that number is. So whatever form of 1 we pick needs to get rid of the square root on the bottom. Okay, that's our big no-no. No square roots on the bottom of fractions. And in this case, to get rid of that square root, we need to go back and look at this page and say, well, what do we do right here, right, with this square root of 6 times square root of 6 or any of these? If we multiply by that square root again, it's going to get rid of the square root. So let's do that. Multiply by the square root of 5 on the bottom. But to make this 1, we have to also multiply by the square root of 5 on the top. Okay? When we do that, we are left with 5 on the bottom and 3 square root of 5 on the top. Okay? Let's do the last one here. So we multiply by square root of 3 over the square root of 3 right there across the bottom here. Really what we're doing, I didn't do this on that very last example, but what we're doing here is multiplying the insides of our square root, so we get square root of 9 on the bottom, and then 9 square root of 3 on the top. Okay, well, now what is the square root of 9? Well, it's 3, and we still have 9 square root of 3 on the top. Can we simplify anything? In this case, yes. We can simplify this 3 and the 9, and we know that reduces to 3 over 1, so our answer here is going to be 3 times the square root of 3. Okay, now what happens if we have a square root over a square root? This is in like the exact same thing as this right here. So the blue and the pink, those are the exact same, and we can just divide from here. So 12 divided by 6 is 2. The square root of 2, well, we can't simplify that. There's no perfect square that will factor into that, and so that is our answer. The next thing I want to look at is one more of those, and then we're going to look at a few other examples here. So again, this fraction is exactly the same as the square root of 18 divided by 2, which is the square root of 9, and the square root of 9 is 3, so this one simplified very nicely for us. All right, the last one that I want to talk about, or last type of problem, are these right here. So when we're looking at this, remember squaring means we multiply something by itself. You can think about this as like distributing our exponent into those two different things in here. So this is like 2 squared times the square root of 5 squared. Okay, well 2 squared is 4. The square root of 5, remember this rule? The square root and the square are inverses, and so this turns out to be just 5, so we need to multiply 4 times 5 and we get 20. Okay, same rule here. We need to think about distributing the square into both terms. So we have 10 squared times the square root of 7 squared, and if we hop back over to that other slide, again, just like these guys, we have it squared. It turns out to be whatever is on the inside of that square root. So this is going to be times 7, and 10 squared is 100, so this answer would be 700.